So this section 7.10 is all about the introduction of the kinetic molecular theory of gases and how gases behave. And so there really aren't too many practice problems surrounding this. This is more of a conceptual investigation. So why do the gas laws work? The kinetic molecular theory of gases explains the gas laws and some properties of liquids and solids. Some terms used in the kinetic molecular theory need to be explained. Random motion, for instance, means that gas particles travel in straight lines in any direction until they hit something. Perfectly elastic collision means the particles bounce off one another and they don't lose any energy whenever they bounce and collide into one another. There are 5 postulates of the kinetic molecular theory. First is that gases are composed of small molecules that are in constant and random motion. The volume that is taken up by the molecules themselves is insignificant compared to the overall volume occupied by that gas. So if you think about the way that I always like to visualize that is we have this container and 1, 2, 3, 4. Those individual molecules or atoms of a particular gas, the space that they occupy is really that representation is even a little bit exaggerated. They're even smaller than that. They're such an insignificant space. Forces between the molecules are negligible, so attractive and repulsive forces, we can just go ahead and kind of ignore those, except when the molecules actually collide with one another. Molecular collisions are perfectly elastic. That is, no energy is lost when the molecules collide. The average kinetic energy of the gas molecules is directly proportional to the absolute temperature of that gas. So there's that relationship between motion and temperature. Okay, explaining gas pressure using the kinetic molecular theory. Postulates 1 and 3 state that gas particles are in constant motion and are colliding with one another. The particles must also be colliding with the walls of their container. So they are within a confined space and they do come in contact with that. The force of those collisions is the source of your gas pressure. So if they are hitting with a large amount of force, well then your pressure is going to be very high. Now explaining Boyle's law. Pressure is correlated to the inverse of the volume. Consider a gas sample with a certain volume and pressure, but at a constant pressure and number of particles. When the volume of this gas sample decreases, the rate of collisions of those particles with the container walls must increase. So when the volume decreases, the collision rate increases. The high rate of collisions means higher pressure. So as volume decreases, pressure must increase. Explaining Charles's law, the correlation between volume and temperature. Consider a gas sample at a fixed pressure and a fixed number of particles, but in an expandable container at a certain temperature. According to postulate 5 of the kinetic molecular theory, an increase in temperature causes gas particles to have more energy and move at higher speeds. As these faster moving particles strike walls of the container, they cause the container to expand, maintaining constant pressure. So your volume is going to expand, or your volume is going to increase in order to allow for the pressure to basically stay flat and not change. Now, Avogadro's law, the correlation and relationship between volume and number of molecules. Consider a gas sample with a fixed pressure and temperature, but in an expandable container that allows you to add more moles of gas. When the number of moles of gas are increased, the rate of collisions of those particles within the walls of the container, or with the walls of the container, increases. As this greater number of particles strike the walls of the container, they cause the container to expand, maintaining constant pressure. So if you think about it as having a, so you've got all these dots and you have a pressure. Well, now when you add more of those dots, well, if this container shape or size remained the same, then your pressure would go up. But Avogadro's law says that, well, we instead expand the container itself. So your volume goes up as your number of moles and molecules of a given substance go up. So explaining Dalton's law, all the postulates of the kinetic molecular theory consider only the number of particles of gases and not the identities of those gases. This explains why the partial pressure of gas in a mixture is related only to the number of moles of each gas. Now, the last thing of the kinetic molecular theory is a talk of real gases. We've up until now been talking about ideal gases. The average kinetic energy is not the energy of any specific particle. Okay? Any given particle may be well above or below that average. The volume of particles themselves is very small, but it is not zero. At high pressures, when many gas particles are compressed into small volumes, the volume of the particles is more significant. So as you compress that space, compress the container, well, the space that those individual molecules is going to become a little bit more significant. At low temperatures, particles move more slowly past each other, so the attractive and repulsive forces between them have greater effect. Real gases behave more like ideal gases at higher temperatures and lower pressures. Now, I know that this whole section was a little bit of a drinking from a fire hose with respect to the amount of material, and it doesn't quite have so much to do with calculations, which we've kind of grown to appreciate for the first few sections of this chapter. But it's important to understand the kinetic molecular theory and understanding those 5 postulates and being able to use those 5 postulates to get some insight into all the different rules and laws that combine to make that ideal gas law. I hope this is helpful. I'll see you in the next section.